Exponential models growth. Exponential growth is described by functions of the form y equals y naught times e to the kt. Since e to the 0 equals 1, we can see that the initial value of y is y naught. The rate constant k determines the rate of growth. The population of the town of Spruce is S of t equals 1500 times e to the 0.1 t. How long will it take for the population of Spruce to double? So we can see that the initial value is 1500. That number out in front tells you your initial value. We're looking for when S of t is double that value, or when is S of t equal to 3000. Setting S of t equal to 3000, we then solve for t. Divide both sides by 1500 and then take the log of both sides. Then solve for t. I get t equals log 2 over 0.1. Recall that 0.1 is my k value. And in general, doubling time is log 2 divided by k. Human population growth rates vary geographically and fluctuate over time. The overall growth rate for world population peaked at an annual rate of 2.1% per year in the 1960s. Assume a world population of 6 billion in 1999 and 6.9 billion in 2009. Find an exponential growth function for the world population that fits the two data points. Find the doubling time. How fast was the population growing in 2010? We're going to find an exponential growth function. Now recall that y naught is your initial value. So what's our initial population? Well, time equals 0 for this function is 1999, and at that time there were 6 billion people. So for y naught I put in 6.0. Then when t equals 10, y equals 6.9. So I put in 6.9 for y, put in 10 for t, and solve for k. To solve for k, I first divide both sides by 6.0, and then take the log of both sides. Divide by 10, and then after I divide by 10, I pull up my calculator so that I can get an estimate. Now, how many places you use will determine what type of accuracy you want. We're going to round to 2 significant digits, so 3 places. Note that we rounded k and wrote the population function as e to the, or 6 times e to the 0.014 times t. And when you do this, you have to keep in mind that you've rounded. And when you round, you always lose information. Let's find the doubling time for the world population. Recall that doubling time is just log 2 divided by k. So we get about 50 years. How fast was the population growing in 2010? Now, if you want to ask the question how fast, that's asking for a rate of change. So that's derivative. So take the derivative of this function. What is the derivative of an exponential function? Well, it's just that same function back again times the derivative of what's in the exponent. And then you just need to simplify. The year 1999 corresponds to t equals 0. So the year 2010 corresponds to t equals 11. So let's evaluate this for t being 11. We get about 0.098, and that's a billion people per year, or about 98 million people per year. That's the growth rate in 2010. All right, so the rate of population growth in 2010 is about 98 million people per year. In our next video, we'll do decay. Take care and have a great day.